Welcome to Supply Chain Management. In this chapter, we're going to talk about supply chain coordination and the bullwhip effect, the impact on supply chain performance. We're going to identify the obstacles to coordination in supply chain and then discuss managerial levers that help in achieving coordination in the supply chain. So, you did talk about, and we did talk about in the previous two lectures, we talked about aggregate plan and the sales and operations plan, how we are manipulating capacity and demand. However, now we're talking about collaboration across the supply chain. So supply chain coordination improves if all stages take action that are aligned and increase the total supply chain surplus. And so this is important, and it requires each stage of the supply chain to share information and take into account the impact its actions have on other stages. So lack of coordination occurs either because different stages of the supply chain have objectives that conflict, or because information moving between supply chains is delayed or distorted. Different stages of a supply chain may have conflicting objectives if each stage has a different owner, and this is very common. And as a result, each stage tries to maximize its own profit, resulting in actions that often diminish total supply chain profits. So let's take an example. Ford Motor Company has thousands of suppliers from Goodyear to Motorola, and each of these suppliers have many suppliers in turn. Information is distorted as it moves across the supply chain because complete information is not shared between the stages. This distortion, exaggerated by the fact that supply chains today produce a large variety of products, causes difficulty to coordinate the information exchange with thousands of suppliers and dealers. The fundamental challenge today is for supply chains to achieve coordination in spite of multiple ownerships and increased product variety. And so what we see is the impact of this lack of coordination is called the bullwhip effect. Here, fluctuations in orders increase as they move up the supply chain from retailers to wholesalers to manufacturers, and this distorts the demand information within the supply chain and results from a loss of coordination. So let's look at how this bullwhip effect happens. So here is the consumer to the retailer. This is the best demand, the closest we have, and you can see how the demand is going slightly up and down. Now, retailer, in anticipation of the increases, might actually do a little bit more, right? Order a little bit more or a little bit less. So you see, while the consumer sales is kind of flat, this kind of spikes up a little bit more. And the wholesaler, anticipating changes in the retailer's orders a little bit more or less, which results in a lot more spikes to the manufacturer. And then manufacturer, in response to the wholesaler, now look at his spikiness. It's just huge spikes up and down. And as we know from our aggregate plan and sales and operations plan, these huge spikes result in increased costs, and sometimes it can result in the breakdown of the supply chain. So let's look at the effect on performance due to this lack of coordination. It reduces your total profits because your manufacturing costs definitely increase. It increases probably your inventory costs. Your replenishment lead time increases because you're not sure, because of the bullwhip effect. Transportation costs increases. The transportation requirements over time and the suppliers are correlated with the orders being filled. As a result of bullwhip effect, transportation requirements fluctuate significantly over time, and this raises transportation costs because surplus transportation capacity needs to be maintained to cover the high demand periods. Labor costs for shipping and receiving increase. Level of product availability decreases because of the lack of coordination. And then relationship across supply chains, it creates a lack of trust, and that diminishes. So what are the obstacles to coordination? The first one is obstacles. Incentive obstacles occur in situations when incentives offered at different stages or participants in a supply chain lead to actions that increase variability and reduce total supply chain profits. It could be local optimization within functions and stages in the supply chain. That is, each stage kind of looks at its own profit and focuses on themselves rather than coordinating. And then there is Salesforce and incentives which are improperly incentivized, which might cause them to dump products onto the next stage of the supply chain, and that could cause a problem. There are information processing obstacles. This is when information is distorted as it moves through the supply chain, and this could actually happen when you forecast based on orders, not actual customer demand, and there's a lack of information sharing. There could be operational obstacles. This occurs when you order in very large lots, or there's large replenishment lead times, and then there is shortage and rationing, and then this allows people to start hoarding and gaming for the shortage. There are pricing obstacles, and this is based when you have lot size based quantity discounts, and these quantity discounts then increases the lot size. And if you have high fluctuations using trade promotions and short-term discounts offered by the manufacturer, which results in forward buying, and this causes problems in the supply chain. And finally, there are behavioral obstacles. This essentially happens because of the lack of trust. Different stages in the supply chain react to current local situations rather than identifying root causes. Different stages in supply chain blame each other for fluctuations. No stage of the supply chain learns from its actions over time, and there is a complete breakdown and lack of trust here. So here is an example of obstacles due to operational and pricing obstacles. So in this figure, we see both demand and order stream for a firm. A firm places an order every 5 weeks. Observe that the order stream is far more erratic than the demand stream. Because orders are batched and placed every 5 weeks, the order stream has 4 weeks without orders, followed by large orders that equal 5 weeks of demand. A manufacturer supplying several retailers that batch their orders faces an order stream that is much more variable than the demand the retailer experiences. If the manufacturer batches its orders to its suppliers, then the effect is further magnified. In many instances, there are certain focal point periods, such as the first or the last week of a month, where a majority of the order occurs. And this concentration of orders further makes things worse. Now let's look at pricing obstacles. So you look at here, we have the retailer sales and manufacturer shipments. This is an example for chicken noodle soup. Observe that the shipments during peak periods are higher than the sales during the peak period because of promotions offered. The peak shipment period followed by a low shipment from the manufacturing indicates significant, see this drop here, this indicates significant forward buying because of the pricing that the retailer is offering. So what can a manager do to achieve coordination? The first step is to align all the goals and activities and the incentives that every participant in the supply chain works to maximize total supply chain profits. So the first one is to align goals across the supply chain. Now, coordination requires every stage of the supply chain to focus on supply chain surplus or total size of the pie than their individual share. And that's very important. The second part which is to align incentives across different functions. So first was stages in the supply chain, and now we're looking at across functions. And so it is important, like all facility, transportation, and inventory decisions should be evaluated based on their effect on profitability, not total cost, or even worse, just local cost. This helps avoid situations such as a transportation manager making decisions that lower transportation cost but increase overall supply chain cost. You also have to price for coordination. A manufacturer can use lot size based quantity discount to achieve coordination for commodity products if the manufacturer has large fixed cost associated with each lot. For products which a firm has market power, the manager could use a two-part tariff system or volume discounts to help achieve coordination. And the final is altering sales force incentives from selling in to sell through. Any change that reduces incentives for a salesperson to push product to the retailer reduces that bullwhip effect. The second aspect is to improve information visibility and accuracy. So it's important that sales data, actual sales data, point of sale data is visible across the supply chain. The second part is forecasting and aggregate planning has to be collaborative and not be done at local levels. There should be some way to design a single stage control of replenishment using either continuous replenishment program, CRP, or vendor management inventory. We'll go into greater detail on these two a little bit later in this chapter. Managers can improve operational performance by reducing replenishment lead times. This reduces uncertainty of demand during the lead time. They can reduce lot sizes, and that reduces information distortion quite a lot because it's smaller lot sizes, and it reduces the amount of fluctuation that can accumulate between any pair of stages of the supply chain. And finally, we can look at rationing based on past sales and information sharing to limit gaming. To diminish this information distortion, the rationing schemes actually discourage retailers from artificially inflating their orders in case of shortage. One approach is called turn and earn, is to allocate the available supply based on past retailer sales than current retailer orders. Now the final part is to design pricing strategies that stabilize orders. So you want to move from lot size based to volume based quantity discounts. So in lot size, retailers increase their lot sizes to take full advantage of the discount. Offering volume based quantity discounts eliminates this incentive to increase a single lot size because volume based quantity discounts consider total purchases during, let's say, a specified period of time, let's say an entire year. And therefore, volume-based discounts then result in smaller lot sizes and reduce the order variability. You can look at stabilizing prices by eliminating promotions and charging an everyday low price, EDLP, everyday low price. The elimination of promotions removes forward buying by retailers and results in orders that match customer demand. And finally, you want to build strategic partnerships and trust because managers find it easier to achieve coordination at every stage trusts each other. Information distortion can be dampened by practices that assign replenishment responsibility across the supply chain to a single entity. A single point of replenishment decision ensures visibility and a common forecast that drives orders across the supply chain. Two common practices that assign a single point of responsibility are continuous replenishment programs, and vendor managed inventories. In continuous replenishment program, the wholesaler or manufacturer replenishes a retailer regularly based on point of sale data. CRP may be supplier, distributor, or third party managed, and in most instances, CRP systems are driven by actual withdrawal of inventory rather than point of sale data at the retailer level. Vendor management inventory, the manufacturer or supplier is responsible for all decisions regarding product inventory at the retailer. As a result, controller of replenishment decisions move to the manufacturer instead of the retailer. In many instances of VMI, the inventory is owned by the supplier until it's sold by the retailer. One of the problems in VMI arises because retailers often sell products from competing manufacturers that are substitutes in the customer's mind. For example, a customer may substitute detergent manufactured by Procter & Gamble with a detergent manufactured by Lever Brothers. If the retailer has a VMI agreement with both manufacturers, each manufacturer will ignore the impact of substitution when making inventory decisions. As a result, inventories of the retailer will be higher than optimal. So we do come to collaborative planning, forecasting, and replenishment, or CPFR. This is a business practice that combines the intelligence of multiple partners in planning and fulfillment of customer demand. So we are looking here at strategy and planning. The partners in this determine the scope of the collaboration and assign roles and responsibilities and clear checkpoints. So they do a joint business plan here. Then they look at the demand and supply management. A collaborative sales forecast projects the partner's best estimate of consumer demand at the point of sale. As forecasts become firm, then they get into execution, where they convert it into actual orders. Fulfillment of these orders involve production, shipping, and receiving. And then finally, there is analysis. So there are 4 different scenarios in a large-scale CPFR, or collaborative planning, forecasting, and replenishment arrangement. First is retail event collaboration. Then there is a distribution center replenishment collaboration. There is store replenishment collaboration, and collaborative assortment planning. So let's talk about how these where they come in the supply chain and which industries it happens. Retail event collaboration applies to highly promoted channels or categories, and it happens in most industries other than those that practice EDLP, or everyday low price. The distribution center replenishment collaboration often applies to retail distribution centers, or if you have a distribution center. Drugstores, hardware, grocery stores often use this. Store replenishment collaboration is direct store delivery or retail distribution center to store delivery. And this is where mass merchants or club stores like Sam's Club and Costco use this. Collaborative assortment planning. This is for apparel or seasonal goods, especially where we have these large discounts at the end of the year. Department stores and specialty retail use this. For successful collaborative planning, forecasting, and replenishment, you need organizational and technology. A lot of technology is needed. You need to implement this very carefully, and there are some risks and hurdles to doing this. Given the large-scale sharing of information, there is a risk of information misuse. Often one or both of the CPFR partners have relationships with the competitors. Another risk is that if one partner changes its scale or technology, the other partner is forced to follow suit and therefore lose the collaborative relationships. Finally, implementation of CPFR and the resolution of exceptions require close interaction between the two entities whose cultures may be very different. And so it's not an easy thing, but it has a lot of benefits. So let's look at how coordination is achieved in practice. First, it is very important that we quantify the bullwhip effect. Managers should start by comparing the variability in orders they receive from their customers with the variability in orders they place with their suppliers. Get the top management commitment for coordination. This is absolutely vital. You cannot achieve success in coordination without top management commitment to this. Devote resources to collaboration. Again, you have to put in money, time, and effort to get this happen. Communication becomes very, very important. And we have to try and achieve coordination in the entire supply chain network. And technology becomes really important for connectivity. And finally, the benefits of coordination has to be shared across the supply chain. Otherwise, there is no incentive for the other people to buy in. And with this, we finish supply chain coordination.